Hey guys, this is a problem solving video lesson on differential calculus. So in this video I have different kinds of questions regarding derivatives or differential calculus. So the first problem, I will start from the very simple part. So the first problem here is if f of x is pi square, then f derivative is how much? Basically, we need to have some definitions and properties of derivatives. So f of x is equals to pi square is constant number. So the derivative of any constant number is 0. Okay, the derivative of a constant number is 0. Whether it is pi square, 100, 10, negative 50, whatever, if f is a constant number, the derivative of a constant number will be 0. Therefore, the answer for this problem is 0. The second problem is f of x is given. This function is a rational function. And the other thing, the derivative of the function at a is 1. Okay, based on this we will try to find the value of a. First of all, the function f is 6x over x plus a. Okay, so if this is our function, what is the derivative? Here we need to know the property of derivative for quotient. So for example, if we have two functions, a of x over b of x, their derivative can be calculated as a derivative times b of x minus a of x times b derivative of x over the square of the denominator. This is called quotient rule for derivative. So we will apply here the quotient rule for this function. So the derivative of f is 6x derivative times x plus a minus 6x times x plus a derivative over x plus a the whole square. So this is the quotient rule. 6x derivative is, the 6x derivative is 6 into x plus a over, minus 6x into the derivative of this one is the derivative of the constant number a plus the derivative of x. The derivative of x is 1. Therefore, 6x times 1 over x plus a the whole square. So this is our derivative. So f derivative is 6x plus 6a minus 6x. Okay, you can multiply this by 6 by x and 6 by a, so that it becomes like this, over x plus a the whole square. So this is 6a over x plus a the whole square. Now look, our first derivative of this function is 6a over x plus a the whole square. This is the derivative of the function at x. But here what is given, f derivative at a is f derivative at a. Here in place of x substitute a, here substitute a. Therefore f derivative at a becomes 6a over a plus a the whole square. So f derivative at a is 1. So this is 1. This implies 6a over a plus a is 2a. 2a square is 4a square is equals to 1. So this implies 6 over 4a is equals to 1. This implies crisscross this value. So 6 is equals to 4a Now dividing both sides by 4, a becomes 6 over 4 or 3 over 2. So the answer for this is 3 over 2. If g of x is given by the combination of f with x plus 1, and f at 1 is 8, f derivative at 1 is 2, then based on this information we are asked g derivative at 1. Okay, so let us write these things properly. So g of x is already given by f of x over x plus 1 plus f of x squared. Okay, this is the function g. So to find the derivative of the function g, we take derivative both sides. Okay, we take the derivative on both sides, which is the same as f of x over x plus 1 derivative plus f of x the whole square derivative, right? So here on this part we will apply derivative of quotient rule for derivative, and for this part we will use product rule for derivative. So using quotient rule for derivative on this part, we will have f derivative times x plus 1 minus f of x times x plus 1 derivative over x plus 1 the whole square, plus applying product rule for f of x the whole square, we will have 2 times f derivative at x times f of x. So this is the derivative of g. Now let us put these things properly. So this is f derivative at x times x plus 1 minus f of x times, here the derivative of x plus 1 is the derivative of 1 plus the derivative of x, which is 1 itself. So f of x times 1, which is f of x itself, over x plus 1 the whole square, plus 2 times f derivative at x times f of x. Now we are asked the g derivative at 1. So in place of x substitute 1. F derivative at 1 times here 1 plus 1 is 2 minus f of 1 over 1 plus 1 the whole square, which is 4, plus 2 times f derivative at 1 times f of 1. Now f of 1, here f derivative at 1 is 2, and f of 1 is here, f of 1 is 8. So we substitute these values in this equation. Therefore f derivative at 1 is 2 times 2 minus f of 1 is 8 over 2 square is 4 plus 2 times f derivative at 1 is 2, f of 1 is 8. So this becomes 4 minus 8 over 4 plus the whole this thing is 32. Okay, this becomes minus 4 over 4 plus 32. The result is minus 1 plus 32. So the result is 31. So the derivative of g at 1 is 31. If f of x is given here, then we are asked the second derivative of the function at 0. So the function is f of x is equals to x times e to the power of 3x minus cos 2x. So we need to calculate the derivative of the second derivative of the function first. So the derivative of this function is the same as the derivative of x e to the power of 3x minus cos 2x. Okay, so using the property or the rule of derivatives, we can use x is a power of 3x derivative minus minus cos 2x derivative. So this we can apply the product rule here. So using product rule, we can use we can have x derivative times e to the power of 3x plus x times e to the power of 3x derivative, okay, only for this part. But the derivative of cos 2x is minus 2 times sine 2x, apply chain rule. So here the x derivative is 1, therefore e to the power of 3x plus e to the power of 3x derivative is 3 times e to the power of 3x, therefore it becomes like this, plus 2 times sine 2x. This is only first derivative of f. Now the second derivative of this function is the derivative of e to the power of 3x plus the derivative of 3x e to the power of 3x plus the derivative of sine 2x. Okay, so this becomes 3 times e to the power of 3x. Here we will apply product rule, derivative of product rule, derivative for product rule. So it becomes 3 times e to the power of 3x plus 9x times e to the power of 3x plus the derivative of this one is 4 cos 2x. Now this is our second derivative. Okay, so substitute 0 in the second derivative. So this becomes 3 times e to the power of 0 plus 3 times e to the power of 0 plus here, due to this x, this term becomes 0. So the result here is 4 times cos 0. 2 times 0 is 0. So this becomes 3 plus cos 0 is 1. Therefore it becomes 4. So the second derivative at 0 is 10. If f of x is, if this function is given x squared plus 2 ln x is f, then what will be this one? So this is very simple. So we need to know f derivative at x is defined as the limit of f of x plus h minus f of x over h as h approaches to 0, or f derivative at 2 is defined as the limit of f of 2 plus h minus f of 2 over h as h approaches to 0. So knowing this helps us to find the limit of this function as h approaches to 0. So first of all, f of x is x squared plus 2 ln x, and its derivative becomes the derivative of x squared, which is 2x, plus the derivative of 2 ln x, which is 2 times 1 over x. So this is our f derivative. So this limit is the same as f derivative at 2. So f derivative at 2 becomes 2 times 2 plus 2 times 1 over 2. Make x is 2. So this is 4 plus 1. The result is 5. Okay. So the limit of this expression is the same as the derivative of f at 2. Therefore, the answer for this problem is A. If f of x is equals to if f of x is equals to 2 the power of, e the power of 2x plus x minus 3 times cos x, then what is its second derivative? So the function is, our function is e the power of 2x plus x minus 3 times cos x. Then we are asked the second derivative. So the first we need to calculate the first derivative. The first derivative of this expression is e the power of x plus x minus 3 cos x derivative. Then this is e the power of 2x derivative plus x derivative minus 3 into cos x derivative. But here this is 2 times e the power of 2x and x derivative is 1 minus 3 times cos x derivative is minus sin x. Okay, so the first derivative becomes 2 times e the power of 2x plus 1 plus 3 times sin x. Okay, this is the first derivative. Now we can calculate the second derivative from the first derivative. So this is 2 times e the power of 2x plus 1 plus 3 times sin x derivative. So applying the rules for derivative, we can write like this: 2 times e the power of 2x derivative plus 1 derivative plus 3 times sin x derivative. Okay, so this becomes 4 times e the power of 2x, but the derivative of a constant term is 0, and the derivative of sin x is cos x, so it becomes 3 times cos x. So the second derivative becomes this result, which is D. If g of x is given in terms of f and something, look, the function g is the combination of f and something. G of x is equals to x times f of x, minus radical f of x. Then f at 2 is given, f derivative at 2 is given, both of them are 4. So what will be g derivative at 2? So first we need to calculate g derivative itself. G derivative is x times f of x derivative minus the derivative of radical of f. So we apply product rule here. We apply here derivative of radicals. So you can apply chain rule for this, for the radical part. So applying product rule here, we will get x derivative times f of x plus x times f derivative minus the, applying composition rule here, this becomes f derivative over 2 times radical f of x. So this can be written as this is 1, x derivative is 1, therefore this becomes f of x plus x times f derivative at x minus f derivative at x over 2 times radical f of x. This is g derivative at x. Now we calculate g derivative at 2, which is the same as f of 2 plus 2 times f derivative at 2 minus f derivative at 2 over 2 times radical f of 2. Now in place of f of 2, this is 4, this is also 4. Okay, this is also 4. Okay, substitute this result. So the result is 4 plus 2 times 4 minus 4 over 2 in the radical 4. So this becomes 4 plus 8 minus 4 over, this is 2, 2 times 2 is 4. Okay, so this becomes 12 minus 1 or 11. Therefore, g derivative at 2 will be 11. So our answer will be A. The next problem is, which one of the following is the equation of the tangent line to the graph of f of x is equals to 1 over x plus 1 plus cos x. This function is given. For this function, there is a certain line which is tangent to the given function at this point. So we are asked the equation of the tangent line for this function at this point. So usually the equation of a line can be written as y is equals to mx plus b, where m is the slope and b is the y-intercept. Here, using the concept of derivative, the slope can be calculated as the derivative of the function at some point of tangency A. So A is here 0, so we calculate the derivative of the function at 0 to determine the slope. So let us proceed. Our f of x is 1 over x plus 1 plus cos x. So this implies our derivative becomes minus 1 over x plus 1 the whole square minus sine x. Okay, therefore our slope m becomes f derivative at 0, which is minus 1 over 1 minus sine 0. But sine 0 is 0. Therefore, f derivative at 0 is minus 1. This minus 1 is the slope of a line which is tangent to this function, the given function at this point of tangency. The slope is known. Now, y is equals to minus x plus b is the slope of the line. The other thing, to calculate b, we use 0, f of 0. Now, f of 0 is, you can substitute here, f of 0 is 1 plus cos, 1 over 1, 0 plus 1, or let me write it properly. F of 0 is 1 over 0 plus 1 plus cos 0, but cos 0 is 1, so this is 1 plus 1, the result is 0. So the point of tangency is 0, 2. So we substitute this point here. So 2 is equals to 0 plus b. Therefore, the b value is 2. So the equation of the line becomes minus x plus 2, or x plus y is equals to 2 is the equation of a line which is tangent to the given point. Therefore, our answer is C. If f of x is given as x squared over 1 plus x times g of x, g of 2 is 1, g derivative of 2 is 10. Then what is f derivative at 2? Here we need to calculate first the derivative. F of x derivative means the derivative of x squared over 1 plus x times g of x. This is f derivative. So this is this derivative can be obtained by using the derivative for quotient rule. So using quotient rule, we calculate the derivative of x squared first, then 1 plus x times g of x multiplied by this minus x squared into 1 plus x times g of x derivative. Okay, we take the derivative of this expression over 1 plus x g of x the whole square. So here the derivative of x squared is 2x, so we can write this as 2x into 1 plus x g of x minus x squared into the derivative of this one means the derivative of 1 will be 0, right? The derivative of 1 will be 0. Then we take the derivative of x g of x over 1 plus x g of x the whole square. Now here we apply derivative of product rule for this part, x g of x. X g of x derivative means this is x derivative times g of x plus x times g derivative. This is the same as x derivative is 1, therefore it becomes g of x plus x times g derivative of x. We substitute this result here. Okay, so this derivative becomes 2x into 1 plus x times g of x minus x squared into g of x plus x times g derivative at x over 1 plus x times g of x the whole square. So this is f derivative at x. Now we want to calculate f derivative at 2. That means substitute 2 everywhere in place of x. So it becomes 2 times 2 into 1 plus 2 times g of 2 minus 2 square into g of 2 plus 2 times g derivative at 2 over 1 plus 2 times g of 2 the whole square. I used 2 everywhere in place of x. So this means for g of 2 is this value g of 2 is here 1. Okay, g of 2 is 1. So here I will substitute 1. So 1 plus 2 times 1 minus 2 square is 4. 4 into g of 2, which is 1, plus 2 times g derivative at 2 is 10. Okay, so this is over, this is 3 square, because g of 2 is 1, 2 times 1 is 2, 2 plus 1 is 3. So this becomes 4 into, this result is 3, minus 4 times 21 over 9, which is 12 minus 80, this is 21 times 4 is 84 over 9. This is negative 72 over 9. The result is minus 8. Therefore, the derivative of f at 2 is minus 8. Therefore, our answer is A. The simplified form of the derivative of 1 plus sin x over cos x is what? So the function is the ratio of some trig function 1 plus sine x over cos x. So we will calculate the derivative of this function. The derivative of this function means 1 plus sine x over cos x derivative. Apply derivative for quotient rule. So this becomes 1 plus sine x derivative times cos x minus 1 plus sine x times cos x derivative over cos square x. So this becomes sine x derivative is cos x. One derivative is 0, therefore the result becomes cos x times cos x minus cos x derivative is minus sine x, therefore it makes this sign plus, so 1 plus sine x times sine x over cos square x. So this becomes cos square x plus, multiply this sine x here, so it becomes sine x plus sine square x over cos square x. But we know that sine square x plus cos square x is sine square x plus cos square x is 1. Therefore, this can be written as 1 plus sine x over cos square x. So the simplified form of the derivative of this function is 1 plus sine x over cos square x. If f of x is equals to e the power of 2x times sine x, then what is the second derivative of this function? So here the function is a combination of exponential and trig, the product of exponential and trig, and we are asked the second derivative. So to calculate the second derivative, first we need to calculate, or we need to obtain its first derivative. F prime or f derivative is equals to sine e the power of 2x times sine x the whole derivative. This is we apply here derivatives for product. So product rules for derivative tells us e the power of 2x derivative times sine x plus e the power of 2x times sine x derivative. So e the power of 2x derivative is 2 times e the power of 2x times sine x plus e the power of 2x, and the derivative of sine x is cos x. So this is the first derivative. Now we can obtain the second derivative from the first derivative. So taking the first derivative, the derivative of the first derivative will give us the second derivative of the function. So here this can be written as 2 times e the power of 2x times sine x derivative plus e the power of 2x cos x derivative. Here we have this thing and this. We will apply in both these two expressions, we will apply derivatives of the product rule. So take the first one, this one. The derivative of the first expression means 2 times e the power of 2x derivative times sine x plus 2 times e the power of 2x times sine x derivative. This is the first part. And the second one, this will be the derivative of e to the power of 2x derivative times cos x plus e to the power of 2x times cos x derivative. So now this becomes 4 times e to the power of 2x times sine x plus sine x derivative is cos x, therefore 2 times e to the power of 2x cos x plus the derivative of e to the power of 2x is 2 times e to the power of 2x cos x. Now the derivative of cos x is minus sine x, therefore we will have minus e to the power of 2x times sine x. Now we can collect like terms. The like terms are here we have e to the power of 2x sine x, e to the power of 2x sine x. Collecting like terms will give us 3 times e to the power of 2x sine x. The other thing is we have here similar terms, so we can add them. It becomes 4 times e to the power of 2x cos x. So factoring out the common term, e to the power of 2x is common, so inside it will be 3 times sine x plus 4 times cos x. Therefore this will be the derivative, or I mean the second derivative of the given function. So our answer will be C. If y is equals to 3 times sine of 3x squared, then the simplified form of the second derivative is how much? Usually for a function f, the second derivative is denoted by double prime. Sometimes if we have a function in the form of y is equals to f of x, our second derivative can be denoted by this symbol. This is the other notation for the second derivative of the function. So here we are asking the second derivative. So the function is y is equals to 3 times, y is equals to sine of 3x squared. So to get the second derivative, we need to calculate the first derivative first. The first derivative, or dy by dx, is equals to d by dx of sine of 3x squared. Okay, so this is the same as 3x squared derivative times sine derivative of 3x squared. So this is 6x cosine of 3x squared. This is the first derivative. Okay, here the first derivative dy by dx is 6x cosine of 3x squared. So it's very simple. Applying the chain rule for derivative will give us this value, and the second derivative can be obtained from the first derivative. Okay, take the derivative of 6x cos 3x squared. Okay, so applying both product rule and chain rule will give us a derivative of 6x times cosine of 3x squared plus 6x times derivative of cosine of 3x squared. Okay, so this will be 6 times cos 3x squared plus here the derivative of cos 3x squared is minus 6x times sine of 3x squared, applying chain rule, derivative for chain rules. Therefore this becomes 6 cos 3x squared minus 36x squared sine of 3x squared. Therefore, the second derivative becomes, the second derivative of this function becomes 6 times cosine of 3x squared minus 36 x squared sine of 3x squared. So this is our second derivative. Therefore, from the given choices, our answer will be C. If a function capital F is given in terms of another function small f and g, which are compositions, then what is the derivative of capital F at 0? So it's very simple. Let's take the function first. Capital F is the product of small f times small g at some expressions. So to get this result, f derivative at 0, we need to first determine the derivative of the function. So the derivative of the function at x is the same as the derivative of this product. Okay, so applying the product rule for derivatives, we can take f of 2x plus 2 derivative times g of 1 minus x squared plus f of 2x plus 2 times, now we take the derivative of g at 1 minus x squared. So we will apply derivative for chain rule. We will apply chain rule here. Then this becomes 2x plus 1 derivative, which is 2 times f derivative at 2x plus 2. You can take first the derivative of the inner expression, which is 2 times f derivative at 2x plus 2 times g of 1 minus x squared plus f of 2x plus 2. Here the derivative of g of 1 minus x squared can be obtained by using the chain rule. Take the derivative of the inner expression, 1 minus 2x squared. 1 minus 2x squared derivative means minus 2x, then times g of 1 minus x squared. We have this as a first derivative. So rewriting this thing will give us 2 times f derivative at 2x plus 2 times g of 1 minus x squared minus, here we have minus 2x into f of 2x plus 2 times g derivative of 1 minus x squared. Now we need f derivative, capital F derivative at 0. So put x is equals to 0 everywhere here. Put x is equals to 0. So this becomes 2 times f derivative at 2 times g derivative at 1. Due to this x, the whole this thing becomes 0 because of this x. When we take this x is equals to 0, everything becomes 0. Therefore, here f derivative at 0 is this result. But what is f prime at 2? F prime at 2 is 4. Therefore, this is 2 times 4 times g of 1 is minus 5. So this becomes negative 14. Okay, therefore capital F derivative at 0 is equals to negative 14 is the answer. if f of x is ln of radical x square minus 1, then we are asked its derivative. Okay, the derivative of this function means the derivative of ln of radical x square plus 1. Okay, we know that ln of x derivative is equals to x derivative over x, or 1 over x. So applying chain rule or making this short will gives us x square plus 1 derivative over radical x square plus 1. Okay, so this is but here radical x square plus 1 derivative is x square plus 1 derivative over 2 times radical x square plus 1. So this is 2x over radical x square plus 1. So this can be cancelled out. The result is x over radical x square plus 1. Therefore, we can substitute this result in here. So this becomes x over radical x square plus 1 times 1 over radical x square plus 1. This becomes x over x square plus 1. So this is the derivative. If f of x is 2x to the power of 5 minus 3x, then what is the limit of this one? Here we need to know the definition of derivative. F derivative at a is equals to the limit of f of x minus f of a over x minus a as x approaches to a. So if this is the derivative of the function, let's take the given function here. Our f of x is 2x to the power of 5 minus 3x. Therefore, its derivative becomes 10x to the power of 4 minus 3. So now f derivative at 1 is equals to the limit of f of x minus f of 1 over x minus 1 as x approaches to 1. But f derivative at 1 means here you can substitute 1 in the derivative, then it becomes 10 times 1 to the power of 4 minus 3, which is 7. Therefore this is 7. So the limit of f of x minus f of 1 over x minus 1 as x approaches to 1 is 7. So our answer is C. If f of x is given in this way, then what is its derivative at 0? The function is given. It's very simple. The function is e to the power of 3x cos x minus x plus pi over x squared plus 2. This is our function. So to calculate f derivative at 0, we need to calculate first the derivative. So the derivative of this function is the same as e to the power of 3x cos x derivative minus x plus pi over x squared plus 2 derivative. So we apply quotient rule for this part and product rule for this part. So let us proceed. So applying product rule on the first part, on this part, it gives us e to the power of 3x derivative times cos x plus e to the power of 3x times cos x derivative minus, applying quotient rule here, it gives us x plus pi derivative times x squared plus 2 minus x plus pi times x squared plus 2 derivative over over x squared plus 2 the whole square. So let us simplify it. This becomes 3 times e to the power of 3x cos x minus e to the power of 3x sin x, because the derivative of cos x is minus sin x, minus in the bracket here x plus 1 derivative is 1. 1 times x squared plus 2 is x squared plus 2 itself, minus the derivative of this part is 2x, then it becomes x plus pi times 2x over x squared plus 2 the whole square. Now we can take this thing as it is. So let us put things as it is. This is our first derivative. Now we need f derivative at 0. Substitute x is equals to 0 everywhere in this expression. So this becomes 3 times e to the power of 0 cos 0 minus e to the power of 0, because 3 times 0 is 0. Okay, so sine 0 minus 0 square is 0 plus 2, 0 plus 2 minus here 0 plus pi times 2 times 0 is 0 over 0 square is 0 plus 2 the whole square. Now this is 0 because here we have 0 times something. So here e to the power of 0 is 1, cos 0 is 1, e to the power of 0 is 1, therefore 1 times 3 is 3, minus sine 0 is 0, so the product, this thing becomes 0. Therefore here we will have 2 over 2 square is 4, so this is 3 minus 1 over 2. 2 over 4 means 1 over 2, so this is 5 over 2. Therefore f derivative at 0 is 5 over 2. It's 5 over 2. So our answer will be D. Again, we have the derivative of ln function. This function is similar to question number 15 or 14. Our f of x is ln of radical x squared minus 5. So once you know the derivative of ln and the derivative of radicals, it's very simple. You don't need to apply chain rules. So simply you can take, actually it's a chain rule, but you can make it short by writing like this. Ln of radical x squared derivative, x squared minus 5 derivative means radical x squared minus 5 derivative over radical x squared minus 5. So this is, you can take the derivative of this radical, which is x squared minus 5 derivative over 2 times radical x squared minus 5. We have here this 1 over radical x squared minus 5. So this becomes 2x over the product of these two is x squared minus 5. So this can be cancelled out. Therefore, the derivative becomes x over x squared minus 5. Okay, this is 5. This number is 5. So our first derivative for this function will be x over x squared minus 5. So our answer will be A. Here we are asked d by dx of ln x. D by dx means ln x, I mean derivative, right? First derivative of x can be written as d by dx of f of x. here we are asked d by dx of ln of e to the power of 2x. Ln of e to the power of 2x by itself is written as 2x times ln e using the property of logarithm, but ln e is 1, so this is the same as d by dx of 2x. Derivative of 2x is 2. Therefore, the answer for this is 2. If f of x is 2 plus absolute value of x minus 3 for all x, then what is the value of the derivative of f at x is equals to 3? Here, let's see what the derivative of the given function looks like. F of x is 2 plus absolute value of x minus 3. So its derivative becomes 2 derivative plus the derivative of x minus 3, so this is the derivative of 2 is 0, so the derivative of x minus 3 is x minus 3, absolute value of x minus 3 over x minus 3. Okay, so this is our first derivative. The derivative of this function is absolute value of x minus 3 over x minus 3. So if you substitute 3 here, it will be undefined. Okay, the derivative of this function at 3 is not defined. It's undefined or does not exist. So our answer is D. If f of x is ln of x squared plus 2, then what is the second derivative of this function at 1? So the function is ln of x squared plus 2. Then its first derivative will be, let us calculate the first derivative. The first derivative of ln of x squared plus 2 is x squared plus 2 derivative over x squared plus 2, which is the same as 2x over x squared plus 2. Okay, this is our first derivative. Look, our first derivative is 2x over x squared plus 2. Now we need to calculate the second derivative. The second derivative of this function means the derivative of 2x over x squared plus 2 derivative. So apply quotient rule for derivative here. 2x derivative times x squared plus 2 minus 2x times x squared plus 2 derivative over x squared plus 2 the whole square. Now this is the same as 2x derivative is 2 times x squared plus 2 minus 2x into x squared plus 2 derivative is 2x over x squared plus 2 the whole square. So simplifying this will give us 2x squared plus 4, 2x squared plus 4 minus 4x squared over x squared plus 2 the whole square. So our second derivative can be written as, or can be simplified to minus 2x squared plus 4 over x squared plus 2 the whole square. So this implies the second derivative at 1 is equals to minus 2 times 1 square plus 4 over 1 square plus 2 the whole square. So this is minus 2 plus 4 over 1 square is 1, 1 plus 2 is 3, 3 square is 9. This is 2 over 9. Therefore, the second derivative at 1 is 2 over 9. if x squared plus xy is equals to 10, what is the dy by dx at x is equals to 2? So let us evaluate dy by dx at the required number. Given that x squared plus xy is equals to 10, so now we can take both sides by d by dx. X squared plus xy is equals to d by dx, or derivative with respect to x on both sides, but derivatives of constant number is 0. Therefore here it becomes d by dx of x squared plus d by dx of xy is equals to 0. Now here we apply product rule. Therefore this becomes 2x plus y times d by dx of x plus x times d by dy of d by dx of y, which is equals to 0. Here d by dx of x is derivative of x, which is 1. So it becomes 2x plus y plus x times dy by dx. So this can be written as dy by dx is equals to minus 2x plus y over x. This is dy by dx in terms of x and y. Now we are asked this expression at x is equals to 2. Whenever x is 2, substitute here. Whenever x is 2, y will have some values. 2 squared plus 2y is equals to 10. This is 4. Therefore 2y is equals to 6. Y becomes 3. So at x is equals to 2, y becomes 3. So let us evaluate this thing. Dy by dx at x is equals to 2. That means the negative of 2 times 2 plus y becomes 3 over x is 2. So this is 4 plus 3 is 7. 7 over 2 we have minus. Negative 7 over 2 will be the value. What is the equation of the tangent line to this graph? Okay, we are asked the equation of a tangent line to this function at the point 1, 2. To determine the equation of a line, we assume the line will have the form y is equals to mx plus b, where m is the slope, b is the y-intercept, but here slope can be calculated by f derivative at the point 1, f derivative at 1. So the function is this one. So its derivative becomes 6x plus 4. So the slope becomes f derivative at 1, which is 10. Substitute 1 here. F derivative at 1 is 10. Therefore, the equation of the line becomes 10x plus b. Okay. Now to determine b, use the point 1, 2, because the line passes through these 2 points. So I mean through this point. At this point, y is 2 and x is 1. Then this becomes 2 is equals to 10 plus b. Therefore, the b value becomes minus 8. Here, the line is y is equals to 10x minus 8. Or we can take everything to one side. So this becomes minus 10x plus y plus 8 is equals to 0. This is the equation of a line tangent to this function at this point. So from the given alternatives, minus 10x plus y plus 8 Or you can rewrite this thing multiplying both sides by negative. It becomes 10x minus y minus 8 is equals to 0. You can also search this kind of line, which is definitely this one. What is the slope of the tangent line to this graph at the point 0, 5? We will use the same procedure as we did in question number 22. So to find, say the line is y is equals to mx plus b. We need to determine this m and b, but m, or the slope, can be calculated by f derivative at this point, f derivative at 0. But what is f derivative? F derivative is from this function, it is 3 times e to the power of x plus cos x is f derivative. So f derivative at 0 is 3 times e to the power of 0 plus cos 0. Cos 0 is 1, 3 is e to the power of 0 is 1. So this is 3 times 1 plus 1. F derivative at 0 is 4. Therefore, the slope of this line is 4. So here our y is equals to 4x plus b. Now to calculate or to determine the value of b, use this point. Use y is equals to 5, x 0. So 5 is equals to 4 times 0 plus b. So the value of b is 5. Okay. So our line will be y is equals to 4x plus b. Actually here we are asking the slope of the line. So the slope of the line is here. So no need to determine this line. Okay. We are asking only the slope. Therefore, the slope is 4. If f of x is k ln x plus e to the power of sine x, and the second derivative at pi is minus 1, then what is the value of k? So let us first determine the second derivative. F of x is k times ln of x plus e to the power of sine x. So its first derivative becomes k times derivative of ln x, which is 1 over x, plus derivative of e to the power of sine x is cos x times e to the power of sine x. You can use chain rule. So this is the first derivative. Now we can calculate the second derivative. So our second derivative will be the derivative of k over x plus the derivative of cos x times e to the power of sine x. Here we need to apply product rule and chain rule. So this becomes minus k over x squared. Use quotient rule. Using quotient rule we can get minus k over x squared plus cos x derivative times e to the power of sine x plus cos x times e to the power of sine x derivative. So this means minus k over x squared minus sine x times e to the power of sine x plus cos x times cos x is cos square x times e to the power of sine x. This is our second derivative. So our second derivative at pi is minus 1, means substitute pi here, minus k over pi square minus sine pi times e to the power of sine pi plus cos square pi times e to the power of sine pi. Look here, sine pi is 0, therefore this thing becomes 0. So this is the same as minus 1. okay, because f of pi is minus 1, therefore this is f of pi, second derivative at pi, which is minus 1. So let us simplify this thing. So this becomes minus k over pi square. Cos pi is minus 1. The square of minus 1 is 1. E the power of sine pi is 1. Therefore, plus 1 is equals to minus 1, implies minus k over pi square is equals to minus k over pi square is equals to minus 2. So this implies minus k is equals to minus 2 pi square. The value of k becomes 2 pi square. 2 pi square. If f of x is ln of x root x, our function f of x is ln of x root x, then what is its derivative? So the derivative of this function, or ln, is x root x derivative over x root x. But here x root x derivative means applying product rule here, x derivative times root x plus x times root x derivative, which is root x plus x times 1 over 2 root x. Again, this can be written as root x plus x into root x over 2x, which is simplified to like this. So this becomes root x plus half of root x, which is 3 over 2 root x. Okay, so in place of this, we can substitute 3 over 2 root x. So this result becomes 3 over 2 root x over x root x. So we can cancel root x, then the result becomes 3 over 2x. So the derivative of this function will be 3 over 2x.